Welcome friends, I am Tanmay. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today I shall discuss about the application of Henry reaction or nitroalkane. And in previous video I have explained about very basics and concept and mechanism of Henry reaction and preparation of nitroalkane. So I suggest you please go through that video first. It will be helpful because lots of things I have explained in details there will be utilized here. So let's continue the discussion. So today I shall mainly discuss about few examples where you can understand the utilization of this Henry reaction. So let's continue. So Henry reaction, as I told in the earlier video also, is the reaction of a carbonyl and a nitroalkane, and this should have a hydrogen. Okay, and this is sufficiently acidic, which I mean pK around 9's acidity like active methylene group. It is very acidic. And in presence of base, this proton is abstracted and this Nitro-Aldol reaction happens. It means this proton is abstracted, which results a carbon ion which is resonance stabilized in the presence of this nitro group, and this finally attacks here like a aldol condensation. But like aldol condensation, it is not that much reversible because here this produced carbon ion is not that much strong base. It's a weak base. That's why this reaction is so much facile. So what happens? This attacks here in a Baragoni's trajectory angle around 107 degrees centigrade, closer to that. Substitute means change may happen, but that's similar. So I have made a video about that. Please go through that. In addition, I have made many videos about aldol condensation. I'll provide the link. Please go through that. The concept will be completely clear for you. So in presence of base, this anion carbon ion is generated, which attacks here. This opens, and subsequent workup produces 1,2 this nitro-hydroxy compound. And another interesting point is that this is also a stereocenter, this is also a stereocenter, and complete possibility of 4 product possible. For example, this is up, this is up, this is down, one up, one down. In this way, 4 options possible. So let's check the utilization of this product. That is, this is a product of Henry reaction. What is the application? So first of all, it's the nitro. Here nitro group is there, so we can expect that nitro group could be reduced, and it is actually that. In presence of this lithium aluminum hydride or palladium hydrogen, this nitro group is reduced. Means after workup we get this amine. So nitro to amine possible. So 1,2 means, or you can say 1,2 here also. 1,2 hydroxy amine is getting 1,2 hydroxy amine is possible. Okay, and utilization of this method is the preparation of chloramphenicol. So I'll explain just after some time. So this, and second, this nitro group could be utilized for preparation of ketone by Nef carbonyl, which is used acid, or McMurray coupling like in presence of Lewis acid like titanium chloride. So it produces this final ketone. So it's a very good method that this nitro group could be converted into a very useful chemical like ketone using through Nef carbonyl synthesis or McMurray coupling. Actually, I am not going to describe this method details in here. I will make a dedicated video on it where I will explain this. So till now, this understanding what we have learned, that it could be a strategy, means OH, CC, nitro. This thing could be a disconnection approach strategy. For example, in case of aldol, actually I have made a video on retro-aldol where I have explained this thing in details. Please go through that. Retro-aldol, it's a question answer. It appeared in GATE 2018. So this is a retro-aldol type, means when we have HOCC, we can think that it could be prepared using aldol condensation. How? Because we can think that this bond will come here, it will go. So what will be produced? This part will be positive and this part will be negative. So this part is positive, this part is negative. So this is possible in case of aldol condensation. Similar thing in case of nitro-aldol condensation. So this will come here and this will come here. So this is minus carbon ion and this is, so this could be aldehyde and this could be a nitroalkane. So this is a strategy for the preparation, means you can utilize this disconnection strategy to for achievement of retrosynthesis of different compound using this nitromethane derivative or Henry reaction having 1,2 position this thing. Okay, so fine. Now one interesting point is that if R is hydrogen, another thing is if this R1 prime is hydrogen, then this could be abstracted via means you can say E1CB or you can say E2 elimination. So actually possibility of E2 is more. So what happened, this hydrogen would be abstracted, it will come here, it will leave. So ultimately what will produce is a alpha beta unsaturated nitro derivative like aldol, which produces alpha beta unsaturated carbonyl derivative. So you can see this thing could be prepared, and this is, you can see it's a diene along with the electron withdrawing group. So actually, sorry, it's a ene with the electron withdrawing group. So in Diels-Alder it could be utilized, in it this material could be utilized, and actually this happens if we take this. If we take this cyclopentadiene, it reacts and produces a 6-member ring. Okay, so this is, for example, NO2, and that is R1, R2, you can think like that. And actually this methodology could be prepared to prepare industrially value-added material like one stimulant where this NH is substituted something and here this double bond is absent. So this is also possible to prepare this using this. So in Diels-Alder it could be used as a substrate. Another thing. So finally now we will discuss about this example of chloramphenicol. It's an antibiotic. So how this could be prepared using this Henry reaction. For example, you can see here also this 1,2 position amino alcohol is there. So this is a simple, we can say it's a derivative of amine, and this amine could be obtained from the corresponding nitro, and the corresponding this thing, this position, this cleavage could be done in presence of nitroalkane. So in this way we can prepare this antibiotic chloramphenicol using this Henry reaction. Okay, fine. So this is the strategy to prepare this important antibiotic. Now we will discuss another important reaction, that is Trifano-Denjanov rearrangement. I will make a dedicated video on this later on. Just one example how this Henry reaction utilized here. So what happens? First position is base. So first position base, it will produce these NO2, this nitroalkane, this carbon ion, which is resonance stabilized. Second, so it produced and it reacts with this, and ultimately it will produce that, it will attack here and it will produce. So this is a hydroxy. So this is alpha, this is beta hydroxy nitro derivative. So second step, it is hydrogen and catalyst like palladium, this noble metal. So what happened? This NO2 will be reduced to amine. So if NO2 is reduced, now right now you can see it's a 1,2 diamino derivative. So after that, what is this react? This react with NO2 dilute HCl. So what happened? This NaNO2 dilute HCl, what it produces? It react with this to produce the corresponding diazonium salt, and this is OH, this is N2, and this is a very good leaving group. So what happened? It leaves. Consequently, this oxygen pushes its lone pair and this group migrates, and ultimately this results in the preparation of a higher size ketone. So from cyclohexane 6-member we are getting cycloheptane, that is a 7-member. So this is a unique strategy for the ring expansion, and this is called Trifano-Denjanov rearrangement. Another thing is that such type of compounds could be utilized in case of sodium periodate to make ketone dedicatedly. Okay, so these are the application of this Henry reaction. So if you like my teaching, please give a like and share this video among your friends so that many people will be benefited. And finally, subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. So see you in my next video. Stay happy, stay cool.